Here we go. We're live. So we are back with our next edition of the All Things Facades podcast, and we got the glass experts on with us, Kyle and Kayla. So I think everybody knows you guys, but I'm going to give you guys a second to both introduce yourselves. And I think you guys have a pretty nice chemistry and kind of mix between the two of you in terms of your specialty areas. I've seen both of you guys on interviews and podcasts, and you guys have a kind of a nice back and forth going on between the two of you. So I guess a little bit of context about obviously what you both do, but also the marriage and that chemistry and how it works.
Yeah, go ahead, Kayla.
Yeah, so Kayla Natividad. I'm a architectural technical services engineer with NSG Pilkington, and I've been with Pilkington for like 7.5 years now. Kind of just catching all the odds and ends of building performance and glass performance and different codes, requirements, lead, things like that. And my background is actually in civil engineering. So I have a PhD in civil engineering with a focus in structures, and all my research was in glass strength. So kind of just a general catch-all glass nerd.
Yeah, thanks. And I'm Kyle Sword. I've been with the company for 25 years. I've been in the glass industry for almost 30. I am currently the R&D director. I was in business development, but most of my time in glass has actually been in manufacturing. I've got a degree in ceramic engineering from the Ohio State University and an MBA. And so really, like, Kayla's the smart one of the two of us. I've just made and melted dirt a bunch. And so I know a lot about the glass manufacturing process, and then I've seen a lot of places where glass goes. So lots of different, markets and technologies and stuff like that. And then I get involved in like lots of weird glass stuff, glass art and, lots of different places, and like to try to be pretty creative and look for ways to do different things. And then I'll use Kayla as the sounding board to go like, is this even possible? Like this wacky idea that I have, is that something you can do? And so it's nice to actually know that there's really smart people around you that can support you with some of the, sort of concepts they have.
That's how I feel on this podcast. I just have smart people on to do most of the talking. So it sounds like this is mostly going to be us asking Kayla questions.
Yeah, for sure.
And that's kind of where I mainly want to go with this discussion is I know Kayla is very technical, and Kyle, I know you have sort of global experience. You're in Ohio now, but what I think is just so fascinating and interesting is I spent a lot of time in different markets, and the level of awareness, code requirements, sophistication, market by market is such a vast spectrum. So how do you find that balance of what is the right answer and what you should be encouraging or pushing on a project versus what is just the norm in that market and it is what it is? Meaning I still have markets where they ask me for a price to eliminate the low E coating or just go with air fill or do annealed glass instead of heat strengthened. And we're talking pennies on the dollars for these differences, but it's just there's that barrier of entry or people just don't really want to hear it.
Yeah, I think Kyle and I have a very similar approach on this. Is we're just transparent about it. We just say, here's everything that we have for you on the table. We know that these are all of the options, and this is where you should go. So let's talk triples, right? Triple AGs, really common in Europe, not so common in the US. And when we start talking about any like building codes or moving things towards requiring triples, well, we don't know that much about it. It's like, yeah, but people do. And people have been doing it for a very long time, and we know it's feasible because it's been done. And so, and then, once you get past that point, then it's like, okay, but here's the reality of where our market is today. This is kind of the best you can pull today. And then this is what's going to happen if you don't do these things. And, and just lay all the options and be openly transparent about what it is that they're actually talking about doing.
Do you think there's an issue with project teams actually being curious how they can improve the fenestration versus just what they're using as a baseline rinse and repeat specification? Meaning sometimes I still see DD sets going out for price and it just says, 1-inch IG with low E glass, and it doesn't really specify the edge, the treatment of the glass, what type of spacer, it doesn't go into specifics. So I guess I come from the consulting side of the business too, and you want to digest the bids, actually understand what's being proposed. But from the contractor standpoint, you could be shooting yourself in the foot by proposing something that is that level of performance, 20% better than what's being specified or what your competition is proposing. So do you think that's an issue in terms of actually getting down to the spec level and making the architect aware of what they're writing in those specs?
Yeah, I do for sure, Adrian. I think there's really three things when I end up talking to people about, different ideas and projects. One is I had a boss a long time ago that told me just follow the math and science and the rest works itself out. So for me, I really try to take that approach. And most of what I do is just try and educate people in the space about the math and the science. Here's this, here's that, here's that. So you got the math and science part of it. You have the economics. You have like, here's how much stuff costs, here's what your choices are and all the alternatives. And sometimes we don't even really understand all the costs that go into it, which is really a big part of it. So you tell people sometimes like, yeah, you're going to spend more on this, but look at your project, look at your overall, like that's the things you have to understand. And then the third part, which I think gets more to your last question here, which is about risk, which is, the math could be good, the science could be good, but it's not what we do today. And I know how to manage the risks and, who to work with and these vendors and this supply chain. And, so when you start introducing risk, everybody's risk averse. Everybody's like, ooh, we've got to do a return on the bottom line. I know the lead time on this is 12 weeks and blah, blah. It's those three things that's where the real hard stuff comes in. So what you've got to do is you've got to, make something really compelling to make people change. And I always hear from people, I say, architects want the latest and greatest thing that's been proven for 10 years, which is for sure the case. I mean, so any new technology, anything different than what we do today is hard. So there's got to be a super compelling math and science reason to do it, a super compelling economic reason to do it, or you've got to just be like, here's how we mitigate all the risks, but it's those three things is really where the hard discussions come. And that's what you got to do is just spell it out, be transparent, talk to people and just educate. And then let other people make the choices. Be like, hey, here's where we're at. We might not be the best choice for you. That's okay. If that's where you're at, as long as you give people all the alternatives and options, they'll come back. The next project, the next down the road, educate, understand the economics well enough that you can help them, and then help them understand the risk tolerance.
Do people actually look at triple glazing as a risk?
Yeah, I think it's an unknown. Not
an additional pane, an additional perimeter seal. I mean, but still, what more so from like a weight to the structure standpoint, or how is it going to interface with the window manufacturer's glazing pocket standpoint, or just all the above?
Everything, all of that. It is a durability issue. It is once we start doing that, once we start going in and introducing, now you have more area for it to fail, more area for there to be just general error in manufacturing or in installation or in how much. And now we go in and we start talking embodied carbon or just general sustainability, and like, what is that trade-off? Is the price point trade-off worth the benefit of your energy savings versus the extra material or the like larger pockets that you might need to hold it? Or if you're talking retrofits and putting something in like that, then it's like, can we even hold this weight? So there's just, depending on who you're talking to, there are a number of issues that people are concerned about. Same thing with and then we start talking thin triples and thin glass, and then it gets even crazier because we're not dealing with a thickness that we're used to dealing with in an architectural market. So you could just
what about reflectivity? What about center light deflection? What about distortion from your center light? What about instead of 6 pounds a square foot, it's 9 pounds a square foot. You've got to have thicker concrete. We've got to be able, there's just everyone. I want every single question answered so that I can be totally transparent, give all the knowledge that you ever might possibly want to understand before you start a conversation. It's like, it's really hard. It's very different than what we do today. And think about the fabrication.
Do you have a lot of architects or project teams referencing past projects and saying, like you just said, I didn't like the reflectivity on that, or I didn't like the distortion when we went with such big fixed lights on the higher wind load areas? I mean, is a lot of it based on reflection of past projects? I want to get into acoustics in a little bit, and that's probably one that is so easily low-hanging fruit that gets VE'd out on every project. But how much of that do you see as when you're talking to architects, them being kind of intentional about those design decisions?
Yeah, and I don't know if this is going to answer like your question exactly, but it references the question you asked prior. Is we do see a lot of, here's the spec that we used in all of these other projects that maybe aren't even in the same area or the same part of the country, or it's like, well, where did you get these numbers from? Why are you trying to achieve these? And I think that some of it is there's a disconnect in where the spec numbers are coming from and then what they're asking for. And so sometimes it does require more of a conversation on our end of saying, well, what exactly are you looking for, right? Because they might hear, it is that they want the latest and greatest kind of thing sometimes. And so, oh, we know that we can hit that with a triple or with a hybrid VIG or with something along those lines. And then they start asking questions, and when we don't have the answers, they're like, well, but this is what I'm looking for. And then you get into asking, okay, well, where do these numbers come from? What numbers are you trying to achieve? What performance are you trying to get to? And then you can break down exactly what it is they're like trying to get at. But yeah, I think some of the uncertainty and some of their certainty about other products do come from past projects that they said, yeah, this worked or no, this didn't. And we only want to cut in like cookie cutter or we never want to see that again, and not really willing to talk through exactly what happened, because everything's project specific, right?
Yeah.
Every project's a little different, so.
I want to get into more later, the more advanced topics like
Yeah.
VIG's been around a long time, but that dynamic glass and all that. But I feel like we still don't spend enough time looking at the basics and how I look at a spec and they specify a center of glass U value or solar heat gain and still can't attribute or look past the fact that that's not going to be your whole window U value. And then what you're actually getting on the building, is that an accurate reflection of what was specified or what's being built? And I guess as the glass people, is that not your problem? You know, when you ask, do you have to make it clear this is your center of glass value? You need to make sure you're consulting with the window supplier to make sure, you know, you're getting whatever true number you need to plug into your energy model.
Yeah. I think every performance value, every model performance value that we send out has a statement that says this is center of glass. Like, this is only center of glass. And I've had a lot of conversations saying, you know, depending on what your frame is, or depending on your edge conditions, you know, your U factor is going to increase. I don't know, and Adrian, maybe, you know, I don't know a single edge, like a frame system that will decrease your center of glass U value. And so it's like, you know, it's going to increase. If you're right on that line, you probably want to drop it a little more. Your solar heat gain is going to decrease every time. So you know that you have a little bit of room there. And then it's up to, like, because we're so disconnected from what's installed, we can't really give great guidance on, yeah, this is exactly what you're going to get when you install it, right? So we kind of give these general rules of thumb of, we know this is going to happen. Talk to whoever is providing your full system or something to, like, figure out how to get those actual numbers.
Yeah. So I want Kyle to answer this one because he talks a lot about all the existing buildings with monolithic glass. And the first one I saw was when I was in Houston recently, and I was going to do a video, but I decided to not pick on the hotel. How much of that do you actually see around the country, though? And is it as prevalent as you make it out to be?
Yeah, if the building stock of the U.S. is something like 328 billion square foot of glass, something like that. I got that number from a presentation by Carl Elefante, who's the ex-AIA president. So when you start doing that math and you think, like, okay, 40% of the building stock is single glazed, and 70% of the building stock doesn't meet current codes. You know, so it's massive. It is absolutely massive. And so you have loads and loads of buildings that are just huge energy hogs. And, you know, and it's no fault because they were poorly designed. They were designed in a time when this stuff didn't exist. Double glaze wasn't available. And I mean, it was in the 30s to the 60s somewhat, but really for large scale commercial buildings, not really until the 70s it didn't really get prevalent. And then the economic cycle also comes into effect, which is like, okay, if all I had to put in was a single glazed building, even if double glaze was around, why am I going to increase the cost on this if I can't actually increase my rents? I can't increase the sales price. And that's part of the other issue around a lot of the stuff that we're talking about codes is, where's the cost happening and where is the savings happening? If it's not happening for the same person, probably not going to see a change, right? But the single glazed market is massive. And I think that retrofits on existing buildings is going to just keep increasing. You know, I think people are starting to work out the numbers and the math on that to go, like, fixing these older buildings is going to be a huge opportunity for our industry. It does have significant savings, like the amount of energy that it takes for us to make the glass in those double glazed units versus how much energy and carbon does it take in offsetting the energy reductions in the building. I mean, it's a matter of months. The payback is a matter of months when it comes to CO2. So when you start doing the math, it's like retrofitting existing buildings is such an awesome win. It is such the simple math on it is like, this is a great fix. This market's going to take off. And so I think that opens up the market to a lot of other things that when you're like, well, the framing's there, this is in good condition. How do we want to approach this? Well, then it instead of just saying this is what we normally do in a double glaze, you know, to this code and these products, you know, you might have 10 different solutions that are really good fixes, you know. So I think it opens up the market for VIG, thin triples, lightweight, high performance glazing, secondary glazing, you know, because then weight and form factor and, you know, structural integrity, all those things come into play. And there's all these solutions out there that are different than what we're doing for new buildings. So now you got, okay, well, what else does that mean? I think it's going to continue to grow. So that, you know, that's at least my feeling.
What do people not know about thin triples? From my standpoint, handling in the manufacturing plant, that could be an issue. Obviously, thermal stress or wind loads and meeting deflection might be an issue on a mid to high rise building. But what are other unknowns or things that scare people away?
Well, why would you buy a triple when you only have to buy a double? You know, that's part of the question is you go, okay, if I don't have to ever buy a triple, why would I ever even consider it? You know, and you go, okay, well, I got triples now that work and meet the code. So if somebody wants that, they'll do that. But what people I think don't understand is, okay, well, how does that impact other stuff? How does it impact the structural? How does it impact the framing? think about if you had an old failing curtain wall from 1970s building that you only have a 1-inch glazing channel. So you can't put in an 1.5 or 1.75 triple glaze, but a thin triple will fit there. Well, now retrofitting your existing building's an option to give you really high performance. So it's the weight and it's the form factor and it's the other things that really might change the economics of the situation if you really understood the science of this is what you can get in this sort of a package. That's where you start to really change the discussion. For new construction, though, I mean, we have stuff with triple that works. Why change it? There's, unless the economics changes or the risks changes, why change what we're doing well today when somebody really demands a high performance? But a lot of it comes down to what's the first thing that's going to get cut when you value engineer the project down. It's like, well, what do we have to put in? So that's really where a lot of that starts to change.
How much of your time is spent upfront trying to encourage a certain approach during the design phase, and it's a really good solution, and you have everybody bought in, and now more than ever, you see this aggressive VE exercise being performed on every single project to make it happen. And, is the glass or some of those extra add-on items the first one to go?
Kayla, I'll let you answer that.
Yeah, I think the struggle, like on our end, is we're really disconnected from those conversations. We're pretty far separated from that, right? We are here offering solutions, and we're offering education and how some of these things can work. But when it comes time to being in that room with whoever is deciding this is exactly what we're going to go with, this is exactly, oh, actually, we're not going to put that surface for low E, or we're not going to move to that thin triple instead of a double IG or something. Like we're not part of those conversations, right? And so the most that we can do is just keep talking and keep trying to educate and keep trying to move forward and having these discussions and pushing them, for talking to architects and fabricators and installers and whoever is willing to give us any of their time to just teach how it can benefit them, right?
It could be worthwhile to get to, have you in that room. I mean, it's tough when you're the float glass supplier. You have the IG fabricator, you have the window manufacturer, you have the glazing subcontractor, you have the GC, you have the owner. So it's like 6 steps removed. So is there merit in, if you're not an IG fabricator, if you're just a float glass supplier, is there merit in you having more of a relationship or interaction with that glazing subcontractor so you could have more influence?
I potentially, but I think one of the hard parts of it, as you laid it out, is we're so far removed, and it's kind of interesting with the way that the glass industry is set up, because we're the ones melting the sand, making the glass. We put on a coating, and then it goes out of our doors. And then that same glass, it could hit 1 fabricator, it could hit 2 fabricators, it could hit 3 fabricators, before it even makes its way to being installed. And so, a lot of times I think we kind of prefer that whoever is the one directly selling to the project be the one that's the face of that. And we're happy to support where we can, and we want to have those discussions. And I think we do that really often, but it's important that, in the same way, I wouldn't want somebody coming through and speaking for me and what I'm doing when they're not the ones directly selling that business. We don't want to get in that in between of our customers and their projects, right? Like we are happy to offer the supporting role. And if that supporting role does mean that they want us in the room with them, then we're happy to do that. But yeah, it's kind of a weird disconnect, because we honestly don't know where a lot of our glass goes or which projects our glasses.
No, yeah, it's interesting, and I totally hear you, and that
Yeah.
makes sense. I guess I would just, if it was me, I'd have this heartburn knowing like, okay, they're just listing me as an approved alternate or just item on the, and then it's, so if I don't have that relationship or influence, but I get it, you guys are selling glass, so many different locations, so many different project types that you can only have that much actual hand holding and involvement.
Yeah, so I think we do try, though, in terms of reaching out to architects and having those conversations. I mean, you format your conversations differently when you're speaking to your fabricators versus your architects or your installers, right? And so we try to do a really good job of going through and answering each group's questions and making sure that we are giving that information in the context that they would want it. Because do they care if, with the fabricator, if it's like they need tempered, a fabricator knows, okay, has to be a minimum of 3.2 millimeters, but an architect isn't going to think 3 millimeter versus 3.2 millimeter. That doesn't really make a difference, right? Because they're specing the exact same nominal thickness. And so things like that, we go through and we try to make sure that we're having those discussions. And I think our team does a good job reaching out, and, lunch and learns, or just our technical bulletins kind of being catered to different groups. But yeah, it's just a lot. It's a lot to stretch out.
So I think this could be an interesting topic. I think there's this strange misnomer that like VIG might not work because it's not easily adaptable to some window manufacturer's glazing pocket, and then, or on the other end, triple might not work because it might be too thick or for the glazing pocket. I think that's baloney, because I think it's just designing a new die or glazing bead is very easy if we have a 1/2 inch piece of glass or 2 inch piece of glass, but you do have some that are very off the shelf and don't want to modify. So let's say you are fixed to that 1 inch glazing pocket. I mean, and you want to do a triple glaze unit, you could start to play with the thickness of the lights, whether it's 1/8 inch, 3/16, quarter. Where are some of your limitations with how thick that gap or spacer can or has to be?
You want to take this one, Kyle?
I was going to let you, because I figure you're going to know more about argon and krypton and air and the
Yeah.
thickness of those sort
More
of
so,
things.
I think everyone's used to 1 inch IGU, quarter, half, quarter,
Yeah.
but I don't think they know that you can go smaller than that 1/2 inch. So where do you
Yeah.
start to run into trouble if you have a 1/4 inch spacer, or what have you seen?
Yeah, so I mean I agree with you that I think there's a lot unknown regarding what spacer thicknesses or widths there are, right? And then when we fall into that, how thin can you get commercially today? And then we start getting into that, and it's like, okay, now you're dealing with different gap widths, and uh, it's interesting when you see the curve. But whether you have an air fill, an argon fill, or a krypton fill, they perform like their optimal performances at specific thicknesses. And
Mhm.
you'll kind of start seeing this curve of like kind of poor performance as you approach your optimal thickness. It gets better in your U factor, and then it kind of drops off again. And so, say argon and air, it's a 1/2 inch sweet spot. You'll get the best performance, bang for your buck. When you start going thinner, so let's say we go down to like a 10 millimeter, now about 10 millimeter, 8 millimeter. Now your best performance is actually with krypton, and not with air argon. And so you start getting trade-offs from like, well, now you're dealing with other unknowns like cost, dealing with maybe a noble gas that you're not, or a gas that you're not used to like dealing with, or you don't have on hand, or who can supply that. And yeah, I think really that's the biggest impact I see. A lot of times I don't see as much hesitation in moving from the 6.6 to a 4.8 or something along those lines. I think I've seen people more willing to adapt to that than they are to adapt to your change in your actual spacer width.
Yeah, I mean, I would think if the more panes of glass you're adding, the more surfaces you have to add a low coating. So if you want 2, 3 coatings, you can put it on 2, 4, 6, and all of a sudden get a super performer. But I don't know if going with a smaller spacer than a 1/4 of an inch, I would imagine starts to have trouble maybe from a structural standpoint or even from a assembly standpoint for the fabricator. I would assume there has to be limitations on that end.
Yeah, and I think some of those are some fabricators are more willing to I guess I think it's what each fabricator's capability, right? Some are more willing to take on some of these. Some of them, again, are more risk averse and saying, you know what, actually, we know we have it and we've done it, but we haven't done it in that size, so we're not really willing to make some of those changes or take on that project, and then it goes on to the next person, right?
Yeah.
So
Yeah. So for me, Adrian, if I'm a fabricator, I think, we sometimes talk ourselves out of things being good solutions because we know the right cost, we know the right this, we know right that. So for instance, you take that, I'm a fabricator and I'm making a 1-inch IGU, quarter, half quarter. That's what I make. All my equipment's, double glazed equipment. I'm making, a surface 2 low E, 1-inch IG. And let's say that I want to have a market offering to go into triple glaze. Just taking that outside pane, leaving that alone, putting in a VIG as your inboard light. You don't have to buy new equipment. You got to figure out how you're going to seal that. But now you've got a 1-inch unit that's it's a number 2 low E with a VIG as your inboard. You've got a hybrid VIG IGU that's a triple glaze performance in a 1-inch form factor. If all you want to do is use double glazed equipment and offer a triple glazed in that market space, that allows you that entry into that space that you're like, okay, well, I could sell this. Yeah, but that's going to be more expensive than a regular triple glaze. I'm not even going to mess with it. I'll just make regular triple glaze. But if somebody is really committed to a 1-inch, like let's say, again, for instance, you're retrofitting an existing building, even if it's more expensive than a traditional triple glaze, you have a solution that meets the performance they're looking for and the form factor they're looking for without changing equipment, without investment in capital, without all that sort of stuff. We go, yeah, but that's not as good of a solution as our normal triple glaze because our normal triple glaze is really cheap. Yeah, but when you start adding in your normal triple glaze with framing, with this, with it, nobody's buying triple glaze because all these other costs. Maybe this is a good, it's like a gateway drug into like triple glaze. Like maybe that is a good solution that you could offer. And if people buy it, great. If they don't, great. You're not spending anything, But to me, that's not how we think. We're like, yeah, but this is a better solution because it's cheaper. We can make it lower. We know how to make it, all those sort of things. That to me is one of the real challenges. It's like, how do we change that? I often think of, have you ever seen that infographic about the cost of a cup of coffee? A cup of coffee costs you $4, but if you look at this, the price of the beans is like $2. Well, we're all down here bean manufacturers and we're this big of a corner and we're worried about going from $2 to 2 cents to 3 cents, or even if we don't sell anything, but if I make you, the fabricator, go from 3 cents to 4 cents, we go, oh, nobody's going to buy this. This is way too expensive. Meanwhile, the cost of a cup of coffee is $4. It's like, we're all playing down here in this space that really big picture. That's not where the cost is. It's not in that stuff, So we're talking ourselves out of technologies and ideas that might fit, might be something that's really interesting for other reasons outside of we got a good triple glaze that works, so we know how to make it. There might be somebody who's really like dead set on my building. I got to get something that's 1 inch to make it work.
I don't get the objections I've gotten to VIG haven't been cost related. It's more around uncertainty, lack of use case in the market. And the other one that you touched on is a hybrid VIG. At what point do you get a diminishing point of returns going hybrid versus just going the standalone? Wouldn't you think that the standalone, you get such superior performance compared to your traditional unit that now you're hybrid, you're adding that cost, and I'm throwing numbers out there. You go from an R10, R12 to an R15, but all of a sudden you have that hermetic perimeter seal, the additional one, and all of a sudden now that unit might only last you 20, 30 years.
But if you've got a window unit or a technology that accepts a 1 inch glazing component, and now you got to retrofit it to accept the 1/4 inch glazing component, is that okay? Can you do that? Is that there's that? You're right. It all comes down to the risks, the technology, and the unknowns. But the risks, to me, I agree, is there's a lot of risk and uncertainty around that. But then it's also like, well, I'd have to fix this and retrofit this, and so it's just not a working option for me.
Let's say ignore glazing pocket for 1 second. Both of you put your sales hat on. You're going into a room with an architect, standalone VIG or the hybrid?
I'll let you answer first.
Yeah, I was like, it kind of just depends on what their project is calling for. I mean, full sales hat on, you still don't want to offer a bunk option that just because you might get a little, $1 sign extra over here. If it's not right,
imagine you guys are indifferent. I mean, just think about the pros and cons of each approach. I really like the standalone VIG cell from making, especially really large operable windows, how light that sash could be, versus you go to that hybrid unit. And all of a sudden, yes, you do get superior performance, but I also think there are drawbacks.
No, I mean, I think with each product, whether it's the standalone or the hybrid, there are pros and cons. And you're right, with the standalone, the real benefit is you're able to go through, have your operable sash. You're still lightweighting, you're still able to do a lot of these things. But whenever you talk, large commercial buildings that have floor to ceiling glass or somewhat like that, and then they're not operable. And we start talking about, okay, well, where's your, at what point is a negligible return? And it's an interesting conversation they bring up because we don't think about that when we talk about like roof insulation or anything like that, right? Like your insulation is like I don't even know, it's like really high right now for like roof insulation, and it keeps increasing. And there have been studies that show like your savings are actually maybe like a couple cents a year. Like it's not like at the point that they're at, you're not getting a return. But no one questions moving from an R14 to a 16 to a 32 for a wall insulation or roof insulation, right? And now we're going through and we're talking glass, and this is actually like a multi-use. We're able to see through it. We acknowledge it has the aesthetic performance. So now we're going through and we're saying we can achieve these like really high performances similar to a standard wall in a hybrid VIG. And it's not to say that a standard like monolithic or not monolithic, but standalone VIG isn't well performing, but it just gives another solution to something that we've never been able to have that conversation before this. We've never been able to say we can perform like your wall. We've always had to take this like step back. And so it's in my opinion, it's two different conversations and two different things of what you're looking for. If you're looking for that operable and you're looking for especially retrofit options, I think the single VIG is absolutely the optimal performance. And if you're looking for new construction, I think this is more like you have the things to play around with and figure out what your building performance for your new construction is, because sky's the limit for new construction.
It's
right?
Well, the truth is historically you've been able to offset that vision area with a better performing roof or better performing opaque area. So you do a R5 or R40 roof. It doesn't matter if you have an R4, R5, R6 vision area. It's just the whole building, whole wall performance. Now with some of these energy codes in cities like Boston and Seattle, especially with an envelope backstop, you're limited. If you want to have a highly glazed facade, you have to hit these targets. And I hear the glass industry when you have these discussions of like the battle of the wall and are we going to see more projects with a lower window to wall ratio, the whole glass industry gets super defensive and they're like, who doesn't want your big floor to ceiling glass and all that? It doesn't mean glass is going away. Everybody loves it. And just because you have more spandrel area or more opaque area, I mean, it's still a tremendous industry.
Yeah. Totally agree. Yeah, and I think to your question on whether, what do I see, these things getting adopted? I think in terms of an industry disruption, people can accept taking out 1/4 inch glass, putting in a 1/4 inch VIG, or taking out one type of 1 inch IGU and sticking in a different type of 1 inch IGU. I think it becomes really hard when you're like, we're going to totally change the form factor and the weights and it's too much risk. I don't know. I'm not comfortable enough with it. So to me, I think the things that look really similar to what we're doing today are going to be more accepted than a bigger change of anything. So.
what do you think in 30 years, just like we look back 30, 40 years ago, we're like, how were they putting in monolithic glass? And it was like, well, that was just business as usual. And that's what they knew. From the glass standpoint, 30 or 40 years from now, what are we going to be looking back on today and say, how the heck were they building that way?
Oh. That's really, I don't know. You got me on this, and I got to think through this. I think part of it is how are we not surface 4 Louise, I think makes sense, or triples. In the same way we look back and say, they were already making Louise for surface 2, but no one was using them. And that's crazy that it was just an IGU with no Louis, right? And now moving forward, I think well, yeah, it makes sense that you would have multiple Louis, or it makes sense that you would have more than 2 layers of glass. And I think those are easy ones.
Just as we see climate zone 7, 6, 5, 4, 3, 2, 1, and you can anticipate every 3 years you get your energy code revision, that's basically what's coming next. So we can go up and look at what's happening in Toronto and say, okay, in 3 years we'll be doing that. So do you look at it that way, as sort of adopting a lot of what the European market has accepted in terms of what we'll start to adopt in time? Passive house standards, triple glazing, all of that.
I think some of that's going to happen. I think the economics, in all sorts of different situations are very different here than they are in Europe. The transportation's different, the landfill costs are different, the recycling rates are different, the fuel costs are different. There's all these sort of stuff on the economics, but generally speaking, what we're seeing in Europe in 10 or 15, 20 years is going to be moving this direction. So I for sure see that stuff happening. To me, I'm still a little surprised with some of the subbing that we do in terms of like why don't we just have really high performance windows that you can sit near, instead of just saying, well, we'll allow these different subbing. And I think at that point, something might change where it's like, that's not going to continue to be allowed. And I think that just the older buildings being allowed to just kind of sit idle, that's already started to change in the US, where it's like, you can't just have these horrible energy hog products that are just sitting out there. And, so I think that sort of stuff is starting to change. The tide, I think, is also starting to turn in terms of the carbon impacts around these different things. I mean, it's not moving the needle just yet, but, Kayla mentioned embodied carbon and operational carbon and reusability and all that stuff. It's starting to change. I think at some point we're going to say, being able to have a product that has a life cycle carbon analysis and really understanding that and what you do at end of life, eventually that sort of stuff is going to be like, oh yeah, why were we allowing ourselves to do this back then? I think that's going to start changing, but it's not moving the needle in the US this year, next year, but it's coming. So
yeah, other things kind of leaning on that, like, going through and looking at deconstruction versus demolition. There's a lot of talk. It started stirring in Europe before it started coming here. Now we're starting to hear a little bit about it. We don't really have the infrastructure to do it, which is like, I think a much longer discussion. 30 years, I don't even think we'll be there in 30 at the rate that it's going right now. But I think some of it depends on where some of that funding is willing to go, right? Or like where progress will go, kind of where the money comes. And it just, unfortunately, that's the way it is. And so, from a glass making perspective, from like a manufacturer perspective, I think some of the things are, we're looking at lower embodied carbon manufacturing too, potentially moving more towards biofuels, or hydrogen fuel will be more, once it's more available, then we can start talking about introducing that into our manufacturing here. Once we have that, now we're actually talking about most glass is going to be low carbon glass, because now we don't have that limiting factor of, well, we're kind of limited to using natural gas in this application for the large size of tanks, right? And so I think it just kind of depends on, from our product standpoint, where we are able to find those abilities in each region that we're in. Europe's already looking at it. We don't really have that in North America. And kind of the same thing for, from the architect standpoint, a lot of that's just going to follow, what products are made available, and people's comfort with them. When is it the next best product with 10 years or 15 years of installation and support behind it? VIG has been in Japan for 25 years, Kyle. Is that?
Yep, 25 years.
Yeah, been installed
So
there.
do you
for
go to
25 years.
Japan and you could see just 10 projects you can go visit?
Oh, for sure. Yeah, there's loads of even new construction. The hybrid VIGs are really, really common in new construction. So you get high-rise apartment buildings, all sorts of stuff. Real common over there.
Yeah.
And you don't get any pushback from an aesthetic standpoint with the pillars in multifamily buildings?
The pillars are
people
really
don't
a
notice
non-issue.
it.
They're so small. They're 125ths or 128ths of an inch. So I mean, really, the pillars you don't notice. The cap is a lot of times the arguing point, but mostly that's on like historic buildings and things like that. For new construction, large panes, you stick it in the top corner. It's covered by the blinds. You don't even talk about the cap either. So really, the pillars, in my view, are a non-issue for even residential is a non-issue.
And less abrasive than bird-friendly glazing? No,
Yeah.
no comment there.
It's not going away, but man, it is polarizing. And to talk to some people, they really don't like the aesthetics of some of the bird friendly stuff out there, but it's not going away anytime soon.
No, I hear it. I mean, I see the dot frit patterns and so forth, and that's used a lot in commercial buildings, but I see a lot of pushback in using that in the private multifamily, right? Because it might interrupt someone's view, and they might say, well, the apartment next door, the building next door doesn't have it, so they'll be willing to pay more rent to have a transparent option.
Yep.
Yeah, I think I'm interested to see where those designs go and what kind of happens through all of those discussions.
That's interesting. A lot of BIG in new construction. Why wouldn't we be using case studies, use cases, especially you have a lot of people coming out with objections like the durability of the perimeter edge seal and sizes and can it withstand loads, but you go to this other market overseas and it's everywhere. Is there a large promotional effort to try to gain awareness from that?
We've been doing quite a bit of work on promotion, and there's other people in the U.S. market that are doing promotion as well. I think the tide's starting to turn. I think people are starting to understand that it's not, some gimmick and it's latest and greatest. There's a couple different seal technologies that we've got loads of data on that say the seal's great. There's loads of research and analysis that's been done around the impact of the pillars and the aesthetics and all that sort of stuff. So I think most of the things out there are solvable, but it's not what we do today. So it just takes a while to get that to change. So.
How much discussion do you guys have with the design community about acoustics? I see we see a target specified, and then somebody sends over to the acoustic report, and they say this, and you're near an airport, or you're in an urban environment. And if you're in New York, we have our OER requirements, so it's part of the code. But you go to Atlanta, and somebody says, okay, that's a recommendation, but I don't want to spend X dollars more a square foot to use laminated glass, so VE it out. So do you think it's taken seriously in this market, and where are we headed when it comes to acoustics?
I think you're exactly right that it's all dependent on exactly where you're located. Obviously New York, you have it, Chicago has it. Anytime you're within a certain vicinity of an airport, we see it more in like academia settings too. I think, and especially like hospitals, right? And so I think there's certain building types in certain cities and certain regions that prioritize it more. Honestly, most of the time, a lot of discussions I have with people, they don't even recognize that moving to a laminate could reduce your sound transmission, or using an asymmetric IGU could have some impacts on noise transmission and things like that. And so I think cities may start taking it more seriously, but until it's a requirement, it is just a recommendation, and it's an easy thing to not have to worry about. And then most of the time, if you do get improved performance, it's kind of a happy accident rather than intended.
I remember my first apartment in New York City, I just had a very loud fan that would block out the noise. But the biggest thing for me is staying in hotels. And when you don't have that option in Boston or here, and you hear the beeping and the set, you can't sleep. It interrupts you. So you think this would be like an immediate item that would be addressed in urban environments, but there's just such a lack of awareness of what's moving the needle and what will get you to those targets and what will really make the difference.
Yeah, we mentioned it earlier that I think part of that depends on who's paying the bill versus who's the one inhabiting the building, right?
100%.
And so the person paying for it, the project at the end, isn't the person that's going to be laying there at night being kept up by the dumpsters picking up whatever, and so and I think that's exactly why, whether it's thermal performance, visible visuals, or it's occupant comfort, until it's actually said you need to do this, I think we're always going to be having that battle of is it going to be valued or not.
So again, if it was me and I was, the king of the US and this was all my fiefdom, and I go, okay, so in New York City, for example, it's going to cost me an extra $100,000 to put in acoustic glass in this building, and that building's going to be there for 50 years. So you do the math and you're like, okay, will somebody in a hotel pay an extra 6 cents a night to have a window that they could, because that's really what it works out to, right? And you're like, well, yeah, I mean, that would be dumb not to, but it's not the way that it works. And the same goes with the energy efficiency stuff, Adrian. So it's like, this building's going to be here for 30 years. If I spend an extra $100,000 on getting higher performance windows, literally it's going to be like a 3-month payback in terms of it's going to cost an extra, $1,000 an apartment, but it's going to save you an extra $150, $200 a year. So, okay, it's a little bit longer payback, but still, if you were the king, you'd be like, yeah, for sure, done. It'd be silly for me not to spend my money here, but that's just not how it works. It's like, no, nobody's going to pay that much more. And it's like, how much more are you talking about? Literally, you'd probably be talking about 2 cents a night in a hotel to have better acoustics, but that's not who owns it and who does it. So
that now I'm going to edit the podcast and put a crown on your head, and that's going to be my sales pitch when I try to push laminated glass. It's actually that's an interesting point, because it also depends on the discussion of, is this building owner going to flip it? within 2-3 years? Are they holding on to it? Is it an institution? It's the same discussion as the energy bill. Who's paying it? Is the occupant paying it, or is it central heating cooling system that's being paid by the building owner? And if they're flipping the building, I mean, especially a rental unit, you go and see an apartment, you go in, they show it during the day, it's quiet, nobody picks up on it. But especially if you're investing in an apartment or it's a condo, or it's just it's a different discussion. I mean, like I said, a new project I'm about to start that's on the freeway in a smaller market, maybe not as educated or commonplace to use laminated glass down there. They wanted a 44 STC. And so we had to use double lamy to get there. And months and months and months later down the VE process, all lamy has been eliminated. So now we're going to do a standard 1-inch IG, and it's like 10 years down the line. I don't know.
I was at a hotel out in Denver where like they had, I mean, it was a kind of a crappy double glazed residential window that was in there, but I don't think it was, the window wasn't even the problem. Like the frame didn't even close. So it's like, it's cold and it's in Denver. So there's like this giant breeze coming in the window, and then all I hear is the freeway. And I'm like, you know, as a window guy, I was just so pissed off that like, why am I staying at this hotel? Like I would have paid twice as much to stay at a different hotel. And it wasn't even really the glass's fault. The framing was just so crap.
The glass is fault. You should have done a video and blamed the window guy.
Well, I don't want to throw anyone else under the bus, but I'm like, it wasn't even the glass that I was mad at. It was just like, this frame is so bad. Like there's this big gap. And I'm like, but it's complicated. That's part of the problem with the industry. There's just loads of interconnected stuff. So you got to mitigate risks and figure out your best path, you know?
Well, that's the problem. You could specify the best performing glass, the best performing window in a perfect lab setting, but that actual installed condition, especially if they mess up the operable hinge when they're setting the window, there goes your performance.
Yeah, I had a similar thing happen I was staying in a hotel right next to the train station in Alexandria, and they had a storm window installed, and it looked like thin clear. So I was like, okay, it's not that much for like thermal performance, but it's probably because of the sound of the train. And then I realized that in the corner of the frame there were these holes. So essentially the sound was still creeping in through those holes. It was just, I was like, I understand the intention was there, execution not quite, you know. But yeah, it is exactly that. Like you could go through, you can I don't know, you can spec a Lamborghini, but then you're just gonna
Yeah, it's funny, Adrian. So I did a VIG project in New York at the Professional Children's School. So it's up on Upper West Side on 60th, and there they had, you know, single glazed steel frame casement windows that they wanted to change out to get better thermal efficiency. And after the project, I went in and talked to all the teachers that were in the classrooms and stuff like that. And every one of them couldn't say anything about the comfort level, but they're all like, you know, I used to have to stop class when a bus went down the street or when the traffic went down, and now like the noise is great. I can teach my classes so much better. So that's the thing, is like, well, the value isn't in, you know, the energy, the value, but like if you literally have to stop classes when a bus is going down, think about what a disruption that is to your business, to your sleep quality, to whatever. There is real value in that stuff that we're just not like taking into account. And so I think
seriously enough.
Yeah. So once you're like, here's the real value, you're like, oh, it's another stuff. We should just be doing it, you know? And so I think you just might get to the point where it's like, you just have to accept that here's the new baseline, and then everyone will adjust.
Yep. All right, this was fun, guys. What is the best place for everyone to reach out to you if they have designers or whoever glass related questions?
Yeah, for me, it's my email, kyle.sword@nsg.com. I'm on LinkedIn as well, so I'm pretty active. I'm not as active as I was when I was in business development and R&D, but reach out anytime. As you can tell, I'm a uber glass nerd. I'll talk about glass all day. Like I have like hour-long lunch and learns, and I'll be like, if you guys want me to stay for 4 hours, I'll hang out and stay for 4 hours. Like I could go from subject to subject and talk about glass history and all that stuff. But yeah, reach out on LinkedIn or on email. And again, my goal on a lot of this stuff is like, I don't go in trying to sell a product or project. I want to be able to help educate people to be like, here's the stuff you need to think about. And then if you take that approach, eventually the right things come to you, that it's like, well, this is a good fit for us. Cool. And then we should work, you know, but if there's other ones, it's like, there's a great fit elsewhere. Awesome. You should go with where your best solution is. If it's not me, that's okay. You know, but yeah, I'll talk about glass anytime. So.
Yeah, I'm surprised that we're already at our hour. That flew by. So same. You can reach out on LinkedIn, or you can reach out at my email, kayla.natividad@nsg.com. And I have Adrian like put it right here because the spelling is kind of long. And but, yeah, whether either email or LinkedIn are probably the best ways to get a hold of me.
Thank you both. We'll do round 2.
Yeah, sounds great. Appreciate it.
All right.
Awesome talking to you.
All right, bye-bye.